A population of values has a normal distribution with mu equals 193.5 and sigma equals 49.5. You intend to draw a random sample of size n equals 57. Find the probability that a single randomly selected value is greater than 187.6. So we have to find a probability, and we're trying to find the probability that a randomly selected value is greater than 187.6. So that's what this notation here is indicating to us. So a randomly selected value is more than this specific number. Now, to find this probability, we have a lot of tools at our disposal. But because we know that we're working with a normally distributed set of data, that helps us decide how we're going to go about solving this. And using the normal distribution functions on the calculator is the way to go. But let's take a moment to make sure we have everything organized. And drawing a bell-shaped curve is a great way to do that. So the mean of this bell-shaped distribution is 193.5. So this is the overall population. So this population has a mean of 193.5 and a standard deviation of 49.5. All right, so the mean, of course, is located right in the center, and 187.6 is somewhere less than that. So I'll draw in that value down here. So I want to find this amount of area because I want values that are greater than 187.6. In order to do that, I'm going to use the calculator's function Normalcdf. So Normalcdf finds areas underneath the normal distribution curve, subject to some region that we have shaded, and so the bounds of our shaded region are the first two inputs to the function, so the lower bound and the upper bound. And this upper bound happens to be positive infinity, so I'm going to use e to the 99th power, which is just scientific notation for 1 times 10 to the 99th, so something very large. The last two inputs to Normalcdf are the mean and standard deviation. So the mean I have is 193.5, and the standard deviation is 49.5. Now, if I use the calculator to find this probability, then I would go to second distributions. So the second and vars key gives me the distributions menu. Come down to Normalcdf and give it the 4 inputs that I've come up with. So 187.6, comma, then second and comma gives me the e, and then I can do E99 for infinity, 193.5, and 49.5. So that gives me 0.5474. So that is the probability that a value is greater than 187.6. Now, when you were using Normalcdf, you may have noticed a menu show up, and some of the calculators, the newer model ones those have a menu that shows up when you use Normalcdf, but it's just giving you an ability to type in the 4 inputs in a menu rather than putting them on the home screen in a comma-separated list. It's just for simplicity. So either way you have it, the problem works out the same, and you get the same solution. Now, the reason that looked exactly like a problem from previous sections with normal distributions is because it really was. When we're finding a probability for a single value, then we're using probabilities for normal distributions, effectively using a z-score formula that looks like this: x minus mu divided by sigma. Now, when you are using the calculator, you don't really see this formula being used, but it is taking the values of the mean and standard deviation in conjunction with this formula to standardize these values before giving you the probability. So it's happening whether you see it or not. In the next part, we want to find the probability that a sample of size n equals 57 that's randomly selected has a mean that's greater than 187.6. And that's what's notated here, although they used a capital letter M instead of X bar, just because sometimes that doesn't always typeset properly in a browser. But that's okay, as long as we know what is meant here. Now, because we are finding the mean of a sample, we use a sampling distribution for the mean instead. And the original population was normally distributed, so that means my sampling distribution is normally distributed for any size sample. So I can just draw a normal distribution, but the mean and standard deviation, I need to take into account that I'm using a sampling distribution. Well, the mean of a sampling distribution is just equal to the population mean, so still it's 193.5. But the standard deviation is the original population standard deviation divided by the square root of the sample size that I'm working with. The mean is still located in the center because this is a normal distribution, which is symmetric. 187.6, that value in question, is somewhere to the left. And I'm still shading to the right because I want values that are greater than that. I still will use Normalcdf to calculate this area under the curve. The only difference is when I standardize, I'm standardizing using this formula. X bar minus mu divided by sigma over the square root of n. This comes into play because I have a sample of items that I'm working with. But again, since the calculator is doing things for you, you won't necessarily see that. What you can do is use Normalcdf as you would normally, and it always takes the lower bound and upper bound of your shaded region for the first two inputs. So those aren't going to change. The next inputs, I'll come down to the next line, but they are still the mean of the distribution and the standard deviation. The standard deviation, you have to be careful and make sure you include that it's the original standard deviation divided by the square root of the sample size. Now, let's use the calculator to get our answer. So if you're using the calculator with the menus, it's actually a little bit easier here just because it's easier to see things on screen. So you can do 187.6, the upper bound, second comma to get the E, and then 99 for positive infinity, 193.5, and then lastly the standard deviation. You can type in 49.5 divided by the square root of 57, and it won't store it this way, but when you press enter, well, actually it does, sorry. Most of the time it calculates what that value is as a decimal. Either way, it's okay. We're going to take that, we're going to paste it onto the home screen, and what it's done is it's placed all of this information into Normalcdf for you as we see it over here, and it comes up with the probability of 0.8159. Now, if you don't have those menus and things are a little bit trickier that way, it's still okay, but let me turn them off and show you what you need to do. So second in distributions, get the Normalcdf function and just start typing in your inputs. So 187.6, comma, E99, comma, 193.5, comma, and then just type in 49.5 divided by the square root of 57. And then cursor over to get out of your square root, close parentheses, and it'll work just the same. It's just, it doesn't show everything all on one screen so easily. So sometimes it's just a little bit more confusing to see, but it works the same.